nuclear chemistry, detector, and the application for medical and industry. Detect and measurement of radioactivities. First one, they can use the photographic film. Photographic film, when they expose to light, it will turn darkening. And also, when you expose to radiation, radiation is a form of wave, and it also will darkening. So when you see the degree of darkening increasing, that means that is exposed to the radiation. People wearing this badge, which have a photographic film in the radiation area, so that they have every day when they finish work, they have to develop the film to make sure there is any exposure to radiation on the radioactive site. Geiger counter, another way to detect radiation, and that is a metal tube. A metal tube connect to a metal rod, and in this device it can connect to a battery. So it connect to a battery. And inside of this tube is made of argon gas. Argon atom is an inert gas. They does not conduct electricity. So electron cannot go through. And here is the window. When radiation goes through the window, it will knock the argon gas into argon ion. Argon is an inert gas. It will never become an ion unless radiation. And once they become argon ion or ion conduct electricity. Now this rod and the tube can conduct electricity paths, and it will be detected by the detector. Scintillate counter. Certain crystal, when they meet by gamma radiation, they will flashing with light. And so, in this example, when radiation pass through in this crystal, they will flash. That's called the scintillation counter. Student, you don't need to understand how's the mechanism of these three devices, but you need to know the name of these three devices, which is to detect radiation. Radioactive isotope. They have important application. They use as a tracer in medical industry, biological and chemical research. This radio tracer, they give radiation and is detected by the detector, like in the hospital, detected by this gamma camera. This radioactive isotope, in medical, they use it as a diagnostic tools, which provide information of the organs in the body. They can using this technique, doctor can assess the functioning of the organ as heart, kidney, brain, thyroid, any organ, without needing for an invasive exploratory surgery to find out the problem. Here I give example. So, for example, They're using this as a diagnostic tool to provide information and the functioning of the organ. As to the isotope of iodine, can use it in thyroid. Isotope of iron can use to study about the blood. Isotope of sodium can use it for circulation. Out of all, TC99, which is widely used. Why? Because they have a short life. This half-life is only lasts 6 hours. Why we need to have a short life of radioactive isotope? Radioactive isotope, when it's in the body, it is useful as a diagnostic tool. But you don't want it to stay in the body for too long, because any radiation in long term will cause cancer. Now let's see the use. Thyroid. This radioactive iodine, you can use it to detect the functioning of thyroid. Once it goes through the gamma camera, the radioactive iodine will show. Is the thyroid being overreactive or underreactive in absorbing the radioactive iodine? The functioning of the heart. On this picture, you can see this part of the heart is lack of blood. So if you're using the iron, the radioactive iron, go into the blood, this part should flare up. But it seems this patient that maybe have some heart blockage, so the blood doesn't go through. And this is after the operation, the blood can go through. The brain. To study the brain, like some people suffer from Alzheimer's disease, to see certain part of the brain is functioning, does it flare up when they thinking or not? So this is a diagnostic tool. Kidney. You can see one part of the kidney, it should absorb sodium. But how come the other part of the kidney, they doesn't absorb sodium? Maybe a kidney failure or kidney damage. So all these examples to show this isotope, they're useful to help the doctor to make a correct diagnosis, to provide you with the information without expensive operation to find out the problem of the disease. Industrial application also useful. For example, sodium-24, it have a longer half-life, 15 hours. In the leaking of the underground water or the gas pipe, if you introduce with the radioactive isotope, the tracer, you can use a handheld camera to detect where's the area of leaking instead of to dig up the whole pipe to find out the leak. Gamma camera, they also can detect the weakness of the metal, like the metal fatigue, hairline crack, and poor welding. So when the thickness of this metal is reduced at the floor area, the more gamma camera will pass through, the more gamma radiation will pass through, which can be detected by the detector. And this radioactive detector is useful to detect any metal flaw, as have many use, like the pipeline, the boiler, or if there is a metal fatigue in the aircraft part, the engine component, they all useful, which you can apply. Radioactive radiation of food, for example, this time is not used as a diagnostic tool, but rather they can, if it is strong enough, you will be able to kill cancer cell or kill bacteria or fungi or yeast. So you can use it to sterilize food.